Hey, hello, welcome to the show. It is me, John Park. It's time for JP's product pick of the week. And I'm going to turn on that light right there. There we go. Hello, welcome to the show. Thanks for stopping by today. We've got some people over in our YouTube chat. Thank you for hopping in there. Doug TDY892, smile emoji. Is that a wink? No, it's a smile. Hi. Dave Odessa, Eric Osterley. Hey, nice to see you. It's been a while. Quinman16, hello. And then we've got our, if you're wondering where the chat is, you could check out. Not that. That's just a black hole. You could check out. Let me fix that. Discord. That's our Discord right there. You can get there by heading over to adafruit.it/Discord. Look for this live broadcast chat channel right here. Hey, Thin Man, nice to see you. John Nodge. Hey, Liz, good to see you. Hey, Jim Hendrickson. Hello. Hey, look, it's Sam J. Ohio. Thanks all for stopping by. And let's get on with the show. So what have we got here today? I have a, oh, hi, Todd. Toddbot just showed up in a black hole also. We've got this QR code and URL combo. You can use either one or both. That will take you to the product page where today's product pick lives. This show is broadcast from inside the page. We have stashed 100 of the product pick and may have others, but 100 for sure guaranteed set aside just for the show. And we have a deep, deep discount. I'm going to check it out myself right now by refreshing my page. And yes, indeed, it's going to be 50% off, maximum of 10 per customer. Head on over there if you like. Check it out. If you like surprises, wait just a moment because I'm going to have Lady Ada hop back just a little bit in time to tell us about this week's product pick. So please take it away, Lady Ada.
We have two boards for the BQ 25185. This is a kind of a nice linear charger for a single cell battery from TI. And I really wanted an alternative to the MCP 73 series that we use a lot of. So I kind of made this look like the MCP 73833 breakout. That's like product number 259. It was like one of the first things we made. This charger has a couple upgrades. One, it can do up to 1 amp charge rate. And if you look on the bottom, there's jumpers that you can solder if you want to change the charge rate to be either 250 milliamps or 500. Most people have big batteries these days, so they want 1 amp charge rate. You can also change the battery voltage. This is the first charger we have that can do that. Most are usually fixed. They can either do, like, you can either get the charger chip to do lithium ion or to do lithium ferric phosphate. So this can do LiFePO4, lithium phosphate, whatever, batteries that are 3.65 volts. So you just solder the jumper on the back, you cut the jumper on the front, and now it's 3.65 volt, which is great because you don't have to have separate chargers. You can like configure this whichever way you want. Another nice thing about this charger is it's got charging and fault and power LEDs. There's 3 LEDs, red for fault, like if something went wrong with charging, yellow for it's in charge state, and the power LED green, which will tell you that the load is working. So what's nice about this battery charger is it has separate battery and load connections. So the battery goes in the left slot and your load, the thing that connects to your circuit that you're powering, goes on the right. And this charger has power path, which means that if you have the USB-C plugged in, which means power's coming in, instead of like charging and discharging the battery continuously, it'll automatically take power from the USB, and then whatever power is left over, it will charge the battery. So it'll like charge the battery on the side. This will keep your battery life lasting a lot longer because you're not like constantly charging and discharging. And the load output is regulated to be no more than 4.5 volts. And so even though the USB or DC input can be up to like 18 volts or something ridiculous, the output load is regulated. So it's safe to use with your things that expect no more than 5 volts output. And like I said, the power path is, you know, it keeps your battery, it'll charge it in the background, basically. It's a little bit like your like laptop, like when you plug it in, you'll automatically switch over to the DC power, and then whatever's left over charges the battery. And finally, the last thing which makes it really nice is for a low-cost charger chip, it can do solar charging. So you can connect a solar panel to the DC input, and it's diode protected, so it doesn't conflict with the USB. And you can use it with a 3 or 9 volt, sorry, a 5 to 9 volt solar panel, and it'll automatically change the charging rate so that your voltage on the solar cell doesn't collapse. You don't need a gigantic you don't need a gigantic capacitor to stabilize it. It will automatically like adjust the current that's used for the load or battery charging to keep your solar cell in like a very optimal state. I will say it's not technically max power point tracking, which is a very specific mathematical technique. However, it gets you like 95% of the way there without the cost. It's like built in and it's very inexpensive. This is like under $10.
Yeah, that's right. This is the product pick of the week this week. It is the BQ25185 USB DC solar lithium ion, lithium polymer, lithium phosphate battery charger. Whew, that's a mouthful. So this has become my new go-to LiPo charger. That's how I'm using this one. And one of the reasons is that it kind of replaces, for me, this old standby here. This had a mini USB, that's how old it is. And this was the MCP 73833 charger, but you can see a very similar form factor where in most of my use cases it's USB in and then LiPo battery plugged in to charge it up. And if you need to, there's a load port there as well. So let's, first of all, let me pop up a nice image of it there. A reminder, if you want to go get one or 10 of them, you can get them for half price right now by going to that URL, that QR code right there. And as you can see here, it is by default going to charge at a 1 amp charge rate. The silk screen on the bottom is wrong on some of them, so you can see there that actually should say 500 milliamp and 250 milliamp there. It's been fixed in later revisions of the board, but by default it is at 1 amp, so you can bridge those either to do 500 or 250. But for these bigger batteries that that I tend to use, we can charge those at the 1 amp rate. You can also change the voltage on here to use the lithium phosphate batteries, which by default this is designed for the LiPo LiPoly batteries that we usually use. I've never even touched lithium phosphate batteries. I believe that is more popular in solar charging, using solar panel cells to charge up these lithium phosphate batteries and then run stuff. But this can be used for that. As you can see, it's got a wide range of input voltages that you can give it, particularly if you're using the DC input or the solar input that are on the side there, and you can solder on some little screw terminals if you want to use those. Those are 5 to 18 volts. Otherwise, you're probably going to be using the 5 volts off of USB on that nice USB-C connector up at the top. And what else do we have to say about it? It's got the LEDs to let you know what's going on. So yellow for charging, green for power is good, red is for fault. And it uses the same JST connectors that we use on all of our batteries, and you can also connect a load to that on the one next to it. You can also add a thermistor if you want to have extra heat monitoring for your application. So if you're building something up from this, you can use a thermistor. It also has a chip enable pin on it if you have a reason to turn it off or on entirely. So the other neat thing about it, which Lady Ada mentioned, is this has the power path, which means if we plug USB into it and a battery is being charged and we have a load running, the load is going to draw from USB, and then any leftover is going to head on over to the battery, but we're not going to deplete the battery and then recharge it off of USB and deplete and so on. So it's a smart path, power path there. So let's take a look at a couple things. First of all, here is the site right here for the product. So this is product 6091. If you head there, you can go see. We've got it on this great price right now, $3.48. As Relic said over on YouTube, so many features for such a teeny tiny chip. It really is. If you head to the product page, Learn Guide, which you can scroll down the product page to find this, you'll see some nice photos of this, the pinout, is listed all of the different connectors for doing load, battery, and solar over the pads rather than the connectors if you want. And hold on, let's take a look at, here's the proper silk screen you can see on the back here. So 500 milliamp or 250. If you leave those alone, you'll be charging at the 1 amp rate. And there's your status LEDs. And then if you head on down to the downloads page here, you can see we've got the Eagle layout. We have a 3D model for it on GitHub if you want to integrate it in a project. I used that to build a case that I'll show you in a second, as well as a fritzing object if you're using this to show a circuit diagram. And then there's a link to the data sheet for the TI chip. So this is this BQ25185 chip, and this will tell you all of the salient details there and more, as well as some recommended applications, description of the chip itself. So let's take a look at a more of a close-up here of it. I'll show in action. So here is just a typical application of it. I'm going to plug in USB, and you can see there the green light has lit, meaning we have a good power source, and that could be your DC input, could be your solar input, could be USB input. And it's blinking right now because it's saying I'm not charging anything. So if we plug in a LiPo battery here, this one actually looks like is full, so no yellow light there. Let me see if this other one, I actually have charged up a bunch of batteries, so we may not get to see that. It should just glow yellow while charging. There we go. So that glows yellow while charging. When it does charge fully, that will turn that one off. If there's a fault, I'm not going to create one. We get a little fault LED right there. And then to show a load plus battery application here, you can see I've got battery plugged in. Let me use this other one here. So we've got this one, which you can tell it's full, right? Because it's not, charge indicator is off. And now I'm going to run this. This is a Circuit Playground Express, and I just have a double-ended JST plug on there so that I can go from the JST connector that's on the Circuit Playground Express up to my load output. And you can see there, we're still not yellow on the charge. We're not drawing anything from this. If I unplug my USB source, you can see I'm now drawing from the battery. And then if we go long enough, this isn't using much power here, but if we go long enough, when I do plug this in the next time, we would see charging going on in the battery. So this is kind of a nice application for this because the Circuit Playground Express, oh, there we go, now we're charging, so we used a little bit. Circuit Playground Express has the JST connector, will run off of these battery level voltages, like 3.7 nominal voltage there. Does not have onboard charging, however. And so you can run it off a USB, but in this case, we've got kind of a uninterruptible power supply, right? If you're doing something where you don't want this ever turning off, we're essentially running off of USB power here, but if that power goes out, we do have battery backup running, so that'll keep going and going and going. So the case that I mentioned, just using that 3D model that the Ruiz brothers had posted, I designed a little 3D printed case here. I didn't screw the top down just so you could see it, but that's a nice little easy way to plug in your batteries when you're charging them without having an exposed circuit board sitting out and about. So there's my little, you can see there, a little hard to see, but you can see I've got the yellow charge indicator there. The green light is hard to see. The green LED is there. And then if I go and plug in my Circuit Playground, that's running still. So let's see, what else can we say about it? I'm going to go to the Discord and the YouTube here. So in YouTube, McQuinman16 asks, will this work for making a portable Raspberry Pi? So this one does not have a boost output on it. So we do have version of this with a 5-volt boost, you'd want to use a 5-volt boost chip because this is not guaranteed to be, this is whatever the battery is straight up. So this is going to be 3.7 to 4.2 usually on these LiPo batteries. So I would not use this for making a portable Raspberry Pi. But for things that have a JST, Adafruit things that have that JST connector meant for a battery, either a LiPo or 2 or 3 AA's size, then perfect. Let's see. Yeah, Todd says this is a mission critical Circuit Playground Express. Yeah, so if you have something that you don't want turning off, I envision things that are doing sensor stuff, running up to Adafruit I/O. You want to be able to unplug it, take it somewhere, but not have it drop if it's doing some sort of logging, sensor logging, that kind of stuff. Now, if you're using a Feather, you've got this built in, right? Featherboard has a not as powerful a charger, but it does have a LiPo charger and USB and all that. But for boards like this, for the Gemma and others that can run off of that easily, then there you go. Let's see, what else is there to say about it? I think that covers it all. Let me check my notes. Let me know if you have any other questions. Quinman16 asked for a link to one that does work for that. I think, let me check this one. I would probably have to think about this harder before I'd recommend this as a portable Raspberry Pi solution. But if you go to Adafruit and look up BQ25185, you'll see we've got today's pick, which is this one right here, and that's going to be the cheapest one, especially with the sale today. But then we've added a little more cost to some of these others that have the 5-volt boost. So this one down at the bottom, 6106. Look at that one. I just don't know what the current is. Raspberry Pi, it depends on the Pi, but they really want 2.5, 3 amp. So you're not going to get that right off of a single LiPo like this without some extra work. All right, let's see. Anything else? Sam asks, is the load pin able to go directly into a Feather's battery pin? Yes, and that's exactly how I'm using it on this this example right here. In fact, I'll put my money where my mouth is and find a Featherboard. I don't know if this one's going to do anything. Hopefully it'll light up a little bit. So here's a Featherboard. I'll unplug the Circuit Playground Express, plug the load. This one's going to do nothing. Let me see if I can find a Feather that will light up an LED at least when it's plugged in. All right, how about this one? There you go. Oh, did I reset it? There you go. So Feather running off of, I'll go directly to this one. So there's the Feather running JST cable to the load side of our charger, and that battery is what's running it. So that'll work, and then we can go power path, USB power to Feather. Battery will charge if the Feather isn't drawing the full amount. All right, so I think that should do it. Let's unplug some things here and finish up. A reminder, if you want to go grab 1 or 10 of these while they're on sale, head over to product 6091. And that price will go up a little, will go up to the regular price a little bit after the show is finished. Okay, well, that right there is my product pick of the week this week. It is the BQ25185 USB DC solar lithium ion, lithium polymer, lithium phosphate battery charger with power path. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week. Thanks so much for stopping by, and I'll see you soon. Bye-bye.